Hey guys, it's Nikhil here from 8th ISE from SVCE. In this video, I'll be giving a technical seminar on exploring task offloading in mobile edge computing environment under the guidance of Professor Amruta C. Coming to the contents of this video, we'll be having the introduction, related background, working the applications and the future enhancements of this topic, conclusion, and finally the references. Firstly, we need to understand what is mobile edge computing. So, mobile edge computing is a distributed computing paradigm that brings computation and storage closer to the mobile users to reduce latency and improve efficiency. Why is task offloading important? But before that, it is necessary to understand what is task offloading. So, task offloading is a process where the tasks which are processed on a mobile phone are offloaded to a nearby edge server so that the process is processed in a much faster way, and it also reduces the battery consumption of the mobile device. And why is task offloading important? It enhances the quality of the service for delay sensitive applications, reduces energy consumption, as I've said, and improves the battery life of the mobile devices. So, coming to the objective, we'll be exploring the fundamentals, some implementation techniques, applications, and the future task enhancements of the task offloading in mobile edge computing. Related background. So, the MEC stands out as a promising framework designed to empower delay sensitive and process intensive computation applications. It achieves this by shifting processing burdens away from resource limited mobile devices, instead, routing them to servers positioned at the network's edge. The European Telecommunication Standard Association, that is ETSA, first coined this idea of computational task offloading in MEC environment in the year 2014. At the core of MEC lies the principle of decentralizing network resources to the network's edge, catering to latency sensitive and computation intensive services while enhancing the user experience. Computational offloading stands out as a pivotal research area within mobile edge computing, which aims at maximizing the resource utilization and service efficiency. The key components of MEC: your user devices, obviously, which are the end user devices, which are smartphones, your smartwatches, IoT devices, or any variables, and the edge servers, which are located near the base stations to process offloaded tasks, and the cloud servers, which are held as an withstand for handling the complex computations in case the edge servers are not sufficient. There are two types of task offloading, which is the full offloading and the partial offloading. Full offloading is where the entire task is sent to the edge or the cloud for processing, whereas partial offloading includes only certain parts of the task. Some of the decision factors which decide the tasks to be offloaded include network conditions, energy consumption, task complexity, and the user preferences. The role of edge servers in MEC. Firstly, local processing. It handles computation intensive tasks without relying on the distant cloud data centers, which is an important factor, and the low latency, which is very much important when coming to applications such as gaming, which includes real-time rendering. So it improves the response time for applications such as gaming, augmented or virtual reality, and autonomous vehicles as well. Bandwidth optimization, which reduces the network congestion by processing data locally instead of transmitting it to the cloud. Energy efficiency helps mobile devices conserve battery by offloading tasks. And the real-time decision making, which supports applications requiring real-time analytics such as smart cities and IoTs. Coming to the working or the implementation of how task offloading works in MEC environments, the first step is task classification and decision making. The mobile device identifies a computational task. For example, it might be video processing, gaming, etc. and it evaluates whether to execute the task locally or offload it to an edge server based on the factors like task complexity, device resources, and the network conditions. The second step is task partitioning and offloading request. If offloading is beneficial, then the task is partitioned into smaller components so that the processing is done in a much efficient way. And the mobile device sends an offloading request to the nearest edge server via wireless network. It might be Wi-Fi, 5G, LTE, or other network supports. And the request includes parameters which are required processing power, which is necessary for the task to be processed, the data size of the task, and the expected execution time. The next step is the task execution that happens at the edge server. So the edge server receives the offloaded task and the processes it using its high computational power. The task execution can be of two types as discussed earlier, which is full offloading and the partial offloading. And the final stage is the result transmission and the response to the device. So once the computation is completed at the edge server, the processed data or the result is sent back to the mobile device. And the mobile device integrates the results and displays the final outputs to the user. So here is a flow chart of how the offloading mechanism works. So we have a computation task, suppose T, at the mobile device. If it is compute intensive, then the offloading decision is taken. If not, then the return process to the mobile device. And then when the offloading task decision has been taken, it is checked if the T, which is the task, is time critical. If S, then the T or the task is offloaded to the nearby edge server. If not, then it is sent to the nearest remote mobile cloud server. So once the offloaded task is time critical, then it is checked whether if it can be partitioned into smaller tasks. If yes, then we use the method of partial offloading. If not, then it is processed wholly as a binary offload, where the data is in the form of a binary format. So this gives a brief understanding of how the different step works in the task offloading process. So coming to the applications and future enhancement with respect to this, the applications, smart surveillance and video analytics, which is AI powered CCTV cameras, which offload video processing for real time detection and security. Autonomous vehicles, where edge server process sensor data and navigation, reducing latency for self driving cars. Healthcare and remote monitoring. Wearables offload vital sign processing, enabling instant health alerts and telemedicine. Cloud gaming and AR and VR, which is one of the important application which offloads game rendering and AI processing, ensuring low latency gaming. Industrial IoT and smart manufacturing, where the sensors offload automation and predictive maintenance for efficient production. The challenges when it comes to task offloading: edge devices mobility, edge server mobility, malicious data threats, which is one of the important challenges. Security challenges as well when it comes to data which is sensitive. So it always has a risk of processing through the network and coming back. So there might be chances of data breaches. Heterogeneous service requirements. So different applications need custom resources allocated to it for the processing and making the task scheduling complex. Future enhancement with respect to task offloading, energy efficient MEC, which reduces power consumption in resource limited environments. 5G and MEC integration, which improves the network speed and reliability. Blockchain for security, ensuring secure data transmission. AI powered offloading. So making use of AI is one of the biggest enhancements that can be done. So there is an intelligent task offloading mechanism and adaptive task distribution. Edge federated learning, training AI models at the edge for better privacy. So coming to the conclusion of this seminar, MEC is still in its early stages. requiring further validation and development to adapt to dynamic environments. While computational offloading plays a crucial role in optimizing resource utilization, no single algorithm can universally meet the diverse latency and energy demands of different applications. So, the increasing adoption of IoT devices continues to strain network capacity, necessitating innovative solutions like integrating NOMA with MEC to enhance performance. So, future research will focus on leveraging AI driven optimization, power control techniques, and real time adaptability to enhance MEC's efficiency and reliability. So, this is the technical seminar. Thank you.